Hydrogen peroxide H2O2 decomposes according to the equation that 2H2O2 gives 2H2O plus O2. The rate of decomposition increases as we use a catalyst. So catalyst causes to decompose at a faster rate. A student tested three metal oxide to determine which was the best catalyst. The oxides were manganese 4 oxide, iron 3 oxide, and lead 4 oxide. They are all solid. So these oxides are solid at room temperature. The student used the following apparatus and experimental procedure. So hydrogen peroxide is there connected to a gas syringe. When hydrogen peroxide decomposes, it gives oxygen and water molecule. The procedure is hydrogen peroxide solution was poured into a conical flask first, then manganese 4 oxide was added. The bung was quickly replaced to connect the gas syringe to a conical flask. The procedure was repeated using iron 3 oxide and lead 4 oxide. So the question is, suggest three things you must suggest three things you would do to ensure the metal oxide are compared like fair comparison when using this procedure. So what are the three things we should keep constant for a fair comparison? Number one, the mass of the metal oxide, basically they should have the same mass, same size of the metal oxide should be used, same concentration or same volume of hydrogen peroxide should be there, and the temperature should also be same. So the things for a fair comparison, because this experiment hydrogen peroxide decomposed to give oxygen and water molecule. For a fair comparison, what we should do, we should use the same mass of these oxides, we should use same size, and we should use the same concentration of hydrogen peroxide or same volume of hydrogen peroxide for a fair comparison, because we are finding which of the metal oxide is a better catalyst. State the measurement that student should make to determine which is the best catalyst. So if student want to know which is the best catalyst, how he can make sure? So he should measure the volume of the gas given off in the time taken, because the time produced the same, or measuring the volume of a gas and in a unit time. So a student should measure the volume of a gas and the time to collect the fixed volume of a gas, because we can compare, like example, the one which give 10 cm cube of gas in a shorter time, it's a better catalyst, as in a short time it gives out the product. So we should measure the volume and the time. The student thought that some of the gas escaped from a conical flask before the bung has been replaced. Suggest how this experiment could be modified to prevent this loss. So basically what is happening, a conical flask is there and student, first this was open, student added the metal oxide, then he replaces, and then he placed the bung. So the moment when he placed the bung, that moment what will happen, because the reaction started, so the reaction started, the gas will escape. So how in that case we can work out if we want to make mix a solid with a aqueous solution or a liquid, so we can take a small, like place a small test tube inside the conical flask. So a small test tube will be placed inside the conical flask, and that test tube will be connected with a cotton ball or a thread. So the test tube is there, which is having a solid, and that is connected with a fine thread. So what we will do, we will remove the thread. The moment we will remove the thread, what will happen? The test tube, the metal will come out from the test tube. As a result, the metal will come out from the test tube. The reaction will start. So that does not allow the gas to escape. So this is always the procedure which we take whenever we want to protect or whenever we don't want the gas to escape. So the part here, the student thought some of the gas might escape, so and the bung has been replaced. Suggests how this experiment could be modified to prevent the loss of the gas. So what we can do, we can place a solid into a small test tube, and then we will attach a thread and knock it over. So we can allow this reaction to occur without a loss of gas. The gas won't escape. In part D, another student thought that some of the oxygen produced may have come from the decomposition of metal oxide. Suggest how this idea could be tested. Like student think maybe what happened, instead hydrogen peroxide decompose, some of the metal oxide might decompose. So how student can be sure that there is no decomposition of the metal oxide? So he should measure the mass before the experiment and after the experiment. So weight the metal oxide before the experiment, then filter, then dry, and then reweight again. If the mass does not change, if the mass is same, it means that metal oxide does not decompose. Because student think there might be some oxygen from metal oxide, but how he can be sure that there is no oxygen coming from the metal oxide? So he should measure the mass at the start of experiment. That is first thing. Then what we will do, we will then after the experiment, we will filter to remove metal oxide. Then we will dry, and then we will reweigh again. If the mass does not change, it means the oxygen is not coming from metal oxide. Is it clear that how we can identify which one is a better catalyst? The experiment. So this question is about the preparation of a salt crystals of hydrated sodium sulfate. So we are preparing hydrated crystals of sodium sulfate. So we are using a titration method to prepare a salt, and then from that salt solution we will carry out crystallization to obtain the salt. You are provided with the following apparatus.